In this video, I will show you the best possible method to study for the Junior Psycho Maths exam. I use this method to get the highest possible grade in 6 of my Leaving Cert subjects, getting 100% in both maths and physics. Throughout the video, all you have to do is listen to me read the question, pause the video, attempt the question, and then compare our answers. If you're not sure about any of it, you can look at the way I did the question and then learn from that. Now make sure to always fully attempt the question before you listen to my advice and how I approach the question. I know this video is very long and it would be way too much to do it all in one sitting. So make sure whenever you stop being able to concentrate, take a break and come back to either later that day or even on a different day. Let's get started. Beya has 8 numbered counters. There are 4 red counters numbered 1 to 4 and 4 blue counters numbered 7 to 10. Beya picks 1 red counter at random and 1 blue counter at random. Complete the table to show all 16 different pairs of counters Beya could pick. One has already been done for you. Okay, so the first thing that we have to do here is fill in this table. So by looking at the 2 and 8, we see that they want us to put the number on the left first and the number up top second. So in that case, that's how you get the 2, 8. So it's just showing all the different combinations that Beya could pick. So I'll fill that in now. Okay, so those numbers have been filled in. So now let's look at question B. So we need to find the probability that one of the counters Beya picks is a 7. So let's first look at their whole table. So as you can see, we have a lot of different options. So if we look at it, we have 4 by 4 options, which will give us 16. So what this question is asking is, how many of those 16 include a 7? So if we look at these here, let's highlight them. So we have one here, another one here, another one here, and another one here. So we can say that 4 out of the 16 options will be a 7. Now let's simplify the answer a little bit. So we'll divide both the top and bottom by 4, and that will give us a quarter. Or another way that we could say this is 25%. So either a quarter, 4/16, or 25% will all be correct answers, or 0.25. Okay, so now let's look at part C. So we have to list the pairs of counters where both numbers are prime. Okay, the way that I'd approach this question is, let's start by writing out all the prime numbers that are up to 10, so that we have sort of an idea of what we're working with. So we know that prime numbers are numbers that can be divided by 1 and itself only. So 2 will be a prime number because 2 can only be divided by 2 and 1. Then 3 will be a prime number. It can only be divided by 3 and 1. 4 won't be. 5 will be a prime number. 7 will be a prime number. And then 8 won't be, 9 won't be, and 10 won't be. So 2, 3, 5, and 7 are our prime numbers. Now let's look at the pairs. I'm going to use this highlighter here. The ones that include 2 prime numbers. So we have this 2, 7, then a 3, 7 here. None of these will be. So actually, there will be only 2. So our 2 answers will be 2 and 7, and then 3 and 7. So our answer to this question, our pairs of counters where both numbers are prime, are 2, 7 and 3, 7. The table below shows the distances in centimeters jumped by a group of students during a school long jump competition. So for question A, we have to work out the number of students who jumped less than 240 centimeters. In order to do that, what we'll have to do is add up all the numbers of students who had distances below that. So we add up 0 to 80, 80 to 160, and 160 to 240. So all we'll have to do is 0 plus 2 plus 7, which will give us an answer of 9 for part A. For part B, we have to draw a histogram to show the information in the table. We have to use the axes and scales below. Now let's have a look at how we have drawn this histogram. So from 0 to 80, which is this here, we've drawn it to a distance of 0. So what we're pretty much saying is 0 students jumped between 0 and 80 centimeters. Then 2 between 80 and 160. So we draw a rectangle like that. Then 7 between 160 and 240. 12 between 240 and 320. And finally 3 between 320 and 400. So this is our histogram representing the data in this table. For part C, we have to work out the maximum number of students who could have jumped more than 200 centimeters. Okay, so let's look at our data here. So we know that it definitely won't be these guys here because we know that 2 people jumped between 0 and 160 if we add these 2 together. But then this is what we have to focus on. From 160 to 240, 7 people jumped. So to understand this better, let's draw this out. So imagine this is your sand pit. So this is the distance between 160 and 240. So just choosing 2 random points here. Now, we know that 7 people landed somewhere between these 2 lines. But the issue is we don't know where. They could have all landed to the left, they could have all landed to the right, or they could have landed randomly throughout that distance. So, if we look at the question, it asks, what's the maximum number of students? So if we want to assume the maximum, so just, I'll draw in here, around here would be the 200 point, so halfway between. If we want to assume the maximum, we'll have to assume as many as possible landed after this line. So we put all of them to the right hand side. So we're counting all of the 7 as over 200 centimeters. If we're looking at the minimum, then we want to be really pessimistic and say none of them jumped over 200. But here, we don't know how far they jumped, but we're assuming, so that's how we're working out the maximum number of students who could have jumped more than 200. So to get the final answer, we count this entire 7, this 12, and this 3. So we count these because these will clearly be above 200 as they'll be further in this direction over here. So it'll be 12 plus 3 plus 7, which will give us an answer of 22 here. Okay, so for part D, I drag the table over here so we can see it. So we want to use mid-interval values to estimate the mean distance jumped by a group of students. Give your answer correct to the nearest centimeter. So we have 2 terms that come from statistics that we have to understand here. So first, let's look at what mid-interval means. So mid-interval. So mid-interval is something in the middle, as we can see mid here means in the middle. So in the middle of the interval. So for example, in part C, we were looking at the jumps between, what was it again? So let's have a look here. Between 160 and 240. So 200 would be the mid-interval point. Why? Because it's exactly in the middle between these 2 points. It's 40 from 160 and 40 from 240. So that's what mid-interval points are. So they're a point in the middle. We do that because, as I was saying in the previous question, we're not really sure where people are going to land. So the best thing to do, if we're not being pessimistic, if we're not being optimistic, is to assume they'll all land right in the middle. They'll all land at the 200 point here, because that'll be sort of the most accurate guess, because it'll be right in the middle of our interval. So what we'll have to do is we'll assume all the people that jumped between 0 and 80, we'll assume they jumped 40. For these, 80 to 160, we'll assume they got 120, and so on. So I'm just going to fill these in here. So this will be 280, and this here will be 360. So 40, 120, 200, 280, 360. Those are mid-interval values. Those are the values in the middle. So what we're assuming in this case is that 2 people jumped 120 centimeters, 7 people jumped 200, 12 jumped 280, and 3 jumped 360. So now we got our first part. We're using the mid-interval values. Now let's look at explain what the mean is. So the mean is a form of an average. The way that we calculate mean is all entries over number of entries. So what does that mean? So all entries we're going to add up. So let's say someone jumps 200, we add 200. Someone else jumps 280, we add 280. Another person jumps 200, we add 200, and so on and so on and so on. We divide that by the amount of people who jumped in the end. So the number of entries in this case will be everyone who took part in this competition. So every student that we have. That would be 2 plus 7, which is 9, plus 12, which is 21, plus 3, which is 24. Also, instead of adding them, usually they say it in the question. So let's just see. It's actually, they don't give you the total here. So, but we can just get it by adding them up. So we know that 24 students took part in this competition. So now, how do we calculate the mean? So you can see, usually when they give you a little bit more space in the question, it's for you to use it. So it means that there's some sort of calculations that we have to do. So instead of doing 120 plus 120 plus 200 plus 200 plus 200, that will take a while. What we do to make it a little bit easier is we multiply. So I'm going to say 2 students jumped 120 plus 7 students that jumped 200 plus 12 students that jumped 280 plus 3 students that jumped 360. So those are all of our students. So you can see that we have 2, 7, 12, 3, 24 students. All of that will be over 24. So over the total amount of students. So now let's calculate that. Once that is done, on your calculator you will get 253.3 recurring. This recurring, this little dot on your calculator again just means 3. So 3 forever. So we are asked to give our answer correct to the nearest centimeter. So in this case, we have a 3, which means that we'll be rounding down. So our answer will be 253 centimeters. Okay, so for part E, we have to estimate the median distance jumped as accurately as you can. So for this, we'll be using the mid-interval values that we have from the previous question. So again, we don't know exactly how far people are jumping, so we're going to have to do a bit of estimation. So the median value is the value in the middle. So if we look, let's say if we draw 5 people, so we have 1, 2, 3, 4, 5. So these are 5 people. The heads are more of a difference than the height here, but you get the idea. We want to get the median person. So we want a person who will have 2 people shorter than them and 2 people taller than them. So the person right in the middle. So in this case, it will be this person here because these 2 are shorter and these 2 are taller. So this guy has the median height. Now we want to do something similar, but the issue is here we have 24 students. So you can easily get the median with odd values. You just get the number right in the middle. But with even numbers, there's no number right in the middle. If you think of the number 4, for example, there's no number right in the middle between 1 and 4 because you have 1, 2, 3, 4. In the middle would be somewhere between 2 and 3. So for that reason, we get the number in between 2 numbers when there's an even one. So in this case, if you think about it, we break 24 into 2 parts, that will be 12, and then the one above that will be 13. So if we have 24 entries, our median will be somewhere in between the 12 and the 13. The same way, if you had 4, the median would be somewhere between 2 and 3. So we're going to have to get something between the 12th and 13th entry. So let's do that here. So 2, 7. So we know 9 people are here. So 9 people will be here. So the 12th and the 13th person will be in this box here. Why do I know that? Because it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it'll be 10, 11, 12, 13, all the way up to 21, and then 22, 23, 24. So this will be our median. So a good estimate of the median will be 280 centimeter. So your working out would be finding the median between the 12 and the 13. And seeing as they're about 280, you can get the average of them, which will also be 280. Thomas works as a chef in a restaurant. The table below shows the hours he worked one weekend. His basic pay is €19 per hour. So we see his hours for Friday, Saturday, and Sunday here. So he worked 7, 8, and 6 hours. So A part 1 is how much money in total did Thomas earn for working on Friday and Saturday. Okay, so we're looking at his pay over those 2 days. So first, let's find how many hours did he work on Friday and Saturday. So to get that, we'll have to do 7 plus 8, which will give us 15 hours worked on Friday and Saturday. And to get his pay for Friday and Saturday, because that's what we're looking for, how much he earned, we'll have to multiply those hours by 19. So 15 by 19. And if we check that, that will give us an answer of €285. So with stuff like this, it helps to think of simpler examples. So if you were being paid €10 an hour and you worked for 5 hours, you would get €50. So you do 5 by 10. The same way here, you do 15 by 19 and you get €285 for Friday and Saturday. Okay, so Thomas is paid 50% extra for working on Sunday. How much did he earn for working on Sunday? So first, let's see how much he would earn working on Sunday normally. So in order to do that, we'll have to do 6 by 19, similar to how we did above. And let's see what will that give us. So 6 by 19, that will be €114. So 114 normally. But remember, he makes €50 extra for working on Sunday. So how can we find that? So first, we want to find 50% of 114. So we're going to do 114. You might know already that 50% is a half or 0.5. And that'll make your life a little bit easier. You'll be able to get that quicker. But if you don't, you can get any percentage of a number just by multiplying by that number. So 50 over 100. And that's the same as multiplying by a half. So 114 times 50 over 100. That will give us 50%, which is €57 in this case. Remember that this is extra, so we're going to have to add this on. So €114 plus the €57. So 114 plus 57 is €171. That will be how much he earned working on Sunday. If you're really confident, you could do something like this: 114 multiplied by 150 over 100. And what you're doing here is you're multiplying by what he already got paid and adding the 50 on top of that. So you're multiplying by 150. So you're multiplying by 1.5, which will give you 171 straight away. If this doesn't make sense and the other method makes sense for you, then stick to that one. But if you're really confident, you want to speed up the way you solve these exam papers, this would be a good way to do it. Okay, then for part B. Thomas's gross income was 1,900 last month. He pays tax at a rate of 20%. His monthly tax credit is €312.50. So we have to work out Thomas's net income for the month. First, let's just work out the tax that he paid. So his income was 1,900. Same way as before. To get 20% of that, you want to multiply by 20 over 100. is equal to, so 1900 by, that will give us 380 euro. So 380 euro is how much he is going to have to pay in tax. Okay, so that's his tax. Now, think of tax credits as like a voucher for tax. So it's come to the end of the month, you have to pay your taxes, but tax credits are your voucher. That's how much you're getting off the tax. So it'd be like going to the shop buying a t-shirt for 10 euro, but you already have a 5 euro voucher. So you have to pay less. That's what we do here. So we're going to make the tax smaller by 312 euro and 50 cent. So let's make it smaller by that. So we'll do 380 minus 312.50, and that will give us an answer of 67 euro and 50 cent. That is how much tax he'll actually have to pay because he used his tax credit as a voucher. So now to work out Thomas's net income for the month, all we have to do is do 1,900 minus 67.50. So you can see that normally he pays a lot of tax, but thankfully because his monthly tax credit is that high, he actually will only have to pay 67 euro and 50 cent in tax. So his net income for the month will be 1,832 and 50 cent. Okay, then let's look down to part C here. Thomas puts 2,500 into his special savings account. This account offers interest at a rate of 3.2% per year for 2 years, compounded annually. Thomas does not put any money in or take any money out of the account over 2 years. How much interest will Thomas earn in the first year? Okay, so the first question is pretty straightforward. We have to take the amount of money that we have in the account, take the interest as a percentage, and that will be our answer. So what we'll have to do is we'll have to find 3.2% of 2,500. So in order to do that, we'll multiply it by 3.2 over 100. That will be our interest in the first year. So 2,500 by 3.2 over 100, and that will be 80 euro. So this is sort of what bank accounts are used for. So just the money by sitting in your bank account, it has grown by 80 euro because the bank account gave you an interest rate of 3.2%. Okay, now let's look at the part two. So you have to work out the total amount in the account after the 2 years. So what we'll have to do here is use something called the compound interest formula. So I'll write it out here. So F is equal to P by 1 plus I to the power of T. So that's our formula. Now, what you might think is, okay, 2,500, then we'll add 81 here and we'll add 80 another year. Question done. But that's actually not what happens. So what we have to think about is that 80 euro will now also be in the bank account. It will also count into the 3.2% that we're adding on. So this is what's called the snowball effect. So if you're rolling a snowball at the start, it's getting bigger really slowly. Once you have a big snowball, it's getting a lot of material. That's how these bank accounts work. So the money's growing and then growing on top of itself, and so on and so on. That's why we have to use the formula, and we can't just add 80 two times. So we're just going to fill it in. Final value is what we're looking for. Principal is 2,500. Then 1 is going to be 1 plus interest. Now, interest we have to put in as a decimal, which will be 0.032 in this case. The pair of t, that will be the 2. That's our time. So we have to be careful whether we're compounding annually or compounding monthly. If we're compounding monthly, there are 24 months in 2 years, so we'll have to put the 24, but because it's annually, we'll just put the 2 here. Now let's put that into a calculator. So 2,500 by 1 plus 0.032 to the power of 2. And that will give us an answer here, once we do that calculation, of 2,662.56. Kira is making an orange drink. The orange drink is made by mixing concentrate and water. The ratio of concentrate to water is 1 to 4. For part A, we have Kira makes 15 liters of the orange drink. Work out how many liters of concentrate Kira uses to make the drink. So ratios are relationships between numbers. For every cup of water, for every cup of concentrate that we use, we will use 4 cups of water. For every liter of concentrate, we use 4 liters of water. So no matter what, the easiest way to think about it is we have 5 whole parts. So 5 whole parts. And then it'll be 1 part, there should be concentrate. So 1 part concentrate to 4 parts water, which means that it will be 1/5 of concentrate to 4/5 of water. So whenever you want to figure out ratios, the total will be adding both of the numbers together, and then 1 will be 1 over 5, 4 will be 4 over 5. So you can apply that to any ratio. Let's say we had a ratio of 2 to 7, for example, we would do 2 over 9 and 7 over 9. So now let's go back to the question. So we know that Kira makes 15 liters of orange drink. So we know that 1/5 of that entire thing will be concentrate, 4/5 will be water. So we just get 1/5 of 15. So we can do 15 by 1/5, and that will give us an answer of 3 liters. So that's how we approach this question here. So now let's have a look at part B here. So Kira sells glasses of the orange drink for 20 cents each. So 0.20 of a euro will be 20 cents. Each glass contains 250 milliliters of the drink. Okay, so every 250 milliliters of drink will cost 20 cents. Then we are told that she sells 10 liters altogether, and the total cost was 550. So what we want to do is work out her profit as a percentage of the total cost and give our answer the correct 1 decimal place. So this question can be really overwhelming at the start because we have a lot of stuff going on. We still can go from prices, liters, milliliters, costs, then you want the profit as the percentage. What we have to do with a question like this is break it down into smaller parts. That will make the question a lot more manageable and a lot easier to solve. So the easiest thing to do here, let's just look at the first 3 sentences. So Kira sells the orange drink for 20 cents each. Each glass contains 250 milliliters of drink, and she sells 10 liters altogether. Okay, so if she sells 10 liters, so 10 liters, she sells 10 liters. And each glass contains 250 milliliters. So the first thing that I want to think is how many glasses did she sell? That will help us answer the question. So 250 milliliters, that's the same as 0.25 liters. So 0.25 liters, that's one portion. And then if you know so your maths, you'll know 0.25, 0.5, 0.751. There will be 4 glasses in every liter. So there's 4 glasses in every liter. There'll be 10 liters. So we'll do 4 multiplied by 10. That will be 40 glasses. So she sells 40 glasses. So just the stuff that I was calling out, you want to write that all out. But just because we don't have how much space to write in is big, we're just going to simplify it. So 0.25, then you want to write down, okay, so 4 glasses in every liter, and then we'll have 10 of those liters. So we'll have 40 glasses in total. And we know that they sell 20 cents each. So to get her total revenue, so how much she made of all the glasses. Now we're forgetting about the cost for now. We're just going to do 40 multiplied by 0.2. So you can think about it, 0.2, 0.2, 0.2. Every glass she sold 40 of them, so just do 40 by 0.2, which will give us an answer of €8. So we know that she made €8 of selling them. Okay. €8 is how much she made. Now the total cost was 550. So the profit, so this is the total cost. Oh no, the total cost is going to be 550. This is her revenue. So her profit will be 8 minus 5.50, which will be €2.50. That's the profit. Profit revenue. Now it's not super important to remember words like revenue when you write now. It's just important that you understand the numbers, and when they come up, you understand them. But actually remember them, not the most important thing. The numbers here are the important part. So we have €8, 2.50, and 5.50 there. Okay, now let's work out. So we have the profit, but we want the profit as a percentage of the total cost. Whenever we want profit as a percentage, we want profit as a fraction first of the total cost, and then we want to change that to percentage. So profit 250, a fraction of the total cost, so that just means we put it over the total cost, which is 550, and we multiply this by 100. So we want to do 250 over 550 by 100, and that will give us, so it'll be 0.45 recurring, which means that'll be 45454545. Let's just write out a few of these, and we want to give it the correct one decimal place. So sorry, this here, because we already multiplied by 100, so this will be 45.45%, 45.4545%, and then always important to go back to the question, check so it's correct to one decimal place. So that's going to be 45.5, and the reason it's 5 is because we have 4, 5. We take the second number. If it's 5 or bigger, we go up. So we go up until we meet to the 5, because we're looking for one decimal place. So her profit as a percentage of the total cost is 45.5%. Okay, now let's have a look at question C here. So each glass is approximately the shape of a cylinder with a diameter 6 centimeters and height 10 centimeters. So a diameter of 6, height of 10. Find the volume of a glass correct to the nearest centimeter cubed. So in order to answer this question, what we'll need is get our formula book, as soon as you see any type of this question, area or volume, get the formula book and look to the given shape. So if we look at the cylinder on page 10 of your formula book, you'll have A is equal to 2 pi or h, and V is equal to pi or squared h. So in this case, we always want to look at the question, are we looking for volume or are we looking for area? You see here, we are looking for volume. So the formula, if we copy it down, is V is equal to pi or squared h. From here, very simple, we just have to fill the formula in. And just at the end, we can't forget we need to correct it to the nearest centimeter cubed. So we're going to fill this in as follows. So V is equal to pi, or in this case, is going to be half of the diameter. So 3. So it's easy to get confused by that. Always make sure radius, half of diameter, diameter twice the radius. Then the height is going to be 10 here. So we have V is equal to pi 3 squared by 10. Now it's important to put the brackets like I did there, so that everything is multiplied correctly. Now the squared could be inside the brackets, but we just want to make sure that we're multiplying instead of putting the numbers beside each other into the calculator. That will give us 90 pi, or if we press the SD button on our calculator, it will be 282.7433, and then centimeters cubed, because we're looking at volumes, so we're looking at the cubes inside of this. So there's 282.74 of them. And notice the way I went to 4 decimal places, just so I have that buffer. So whatever decimal points they need me to round up to, I'll have more than enough to work with. So correct to the nearest centimeter cube, that will be, because we have a 7 here, we'll be going up, so it'll be 283 centimeters cubed, which is our answer for part C. A and B are 2 sets. Complete the tables below by shading in each of the given sets in the diagram. So first set that we have is A intersection B. So as the name implies, it's the intersection between them. It's the area here in between them. So we're just going to shade this area in here. The next one, this little diagonal here means less. So what we're saying is A less B. What this means is everything in A that's not in B. So it's just going to be this area here. So A less B. Okay, then let's have a look at question B. So the sets U, P, Q, and S are as follows. So the set U is the natural numbers from 1 to 10. The set P are the numbers 3, 5, 6, 9. The set Q is 3, 5, and 10. And the set S is factors of 10. So when we're working with ones like this, like let's say factors of 10, it's nice to write them out. It'll make your life a lot easier. So let's just go ahead and write those out. So it'll be 1, 2, 5, and 10. So now it's a lot easier. Now we could also write out the natural numbers from 1 to 10, but I think that will be pretty obvious without writing them out. So just 1 to 10. We won't have to think too much about them. So here we have to complete the Venn diagram below by writing each element of the set U in the correct region of the Venn diagram. Okay, so we already have 4, 9, and 8 put in here. So let's always just start from 1 to 10 here, just fill them in. So we have 1, so 1 is definitely going to be in U. It's not going to be in P, it's not going to be in Q, but it's going to be in S. So I'm going to put in 1 here. And we always put just a little dot beside them, because look what happens. Let's say if I put 1, so 5 won't be in here, but let's just say 5. This looks like 15. So we have to be careful. If we want to put a 1 and a 5, we put a dot here and a dot here. So always just when you're writing numbers into Venn diagrams, make sure that you draw the dot in front of it. Okay, so 1 is done. Then 2. 2 is going to be the same actually. It's only going to be in S. Then 3 is going to be in U, P, and Q. So U, it's going to be in the big rectangle. It's going to be in P, and it's going to be in Q. So it's going to have to be in here. And the reason it's not down here is because it's not in S also. So it's only in P and Q. Then 4, we already have 4 put in. 5, let's have a look at 5. So 5 is going to be in P, Q, and S. So it's actually going to be right in the middle here. It's going to be in all of them. Then 6 is going to be in P only. 7 is going to be in none of them actually, so we'll just put it on the outside here. 8 is here, 9 is here, and then finally 10. 10 is going to be in Q and S. So it's going to be here. Okay, so then let's have a look at part 1 here. So you have to list the elements of the set P intersection Q intersection S. So I like to do those in order. So let's have a look at P intersection Q. So we have this shape here, so where the 3 and 5 is. So that's our first shape, and now we want to get the intersection of this shape and S. The intersection of this shape here and all of S will be just 5. So P intersection Q intersection S, just in the center of all of them, is going to be 5. And then for part 2 here, you have to list the elements of the set P less Q. So everything that's in P but not in Q. So everything that's in the red circle but not in the blue circle. So in this case, so we want to just put it in curly brackets like that just to show that we're listing the elements of a set. So you're going to say 6 and 9. A chocolate bar in the shape of a prism is shown below. The front and back faces are each in the shape of equilateral triangles with sides of length 3 centimeters. The other 3 faces are each in the shape of rectangles that are 9 centimeters in length, as shown above. So you need to complete an accurate net of the prism below by drawing in the 4 missing faces. So there's going to be the 3 rectangles and one of the triangles at the end. One of the triangular faces has already been drawn. Each small square in the grid has sides of length 1 centimeter. So this will help us later on in the draw. So we have to think of sort of cutting this shape apart. So I'm going to make a cut here, 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 and here. And I'm going to fold this triangle down here. This will be this one. Then this rectangle to the right, this to the left. That will give me a flat shape here, and then a triangle at the end. So this is going to be 9 squares here. So I'm just going to draw the first rectangle. So that's going to be the base of our shape here. Then I'm going to go down. Be careful not to go past it. And then just the final one here. And that's our base. Now we want to draw the 2 rectangles on the side. So we're going to go 3 up here, 3 across, or 9 across, sorry. And then down here, draw that again. Perfect. And then exact same thing here. Now, for this triangle at the end, there's a few ways to do it. So, one way would be to grab a 60 degree, because we know that equilateral triangles are 60 degrees. So, draw a 60 degree line from here, 60 degree line from here, and see where they match up. Another way, I think this would be a little bit more accurate, is you get a compass. So, you could think your compass sort of like this, and you swing it from here. Then you get the same compass. So first you put the needle here, you swing it. Then you put the needle here, you swing it like so. I'll draw that one again so they meet in a better place. And let's say they meet somewhere in the middle here, and that's where you join. So you have 2 methods of doing it. I would recommend the compass method. That would be sort of more accurate. So imagine we had the 2 swings. So one from here, like here, another one here. And then this will be the point of your triangle. So we'll join this up, of course, using a straight edge. I'm using a tablet here, so I don't have a straight edge, but you match them up, and that will be the net of the prism done. 2 rectangular solids, a cube A and cuboid B, are shown in the diagram below. The edges of cube A have length x centimeters, where x is a real number. Cuboid B has dimensions 5 centimeters, 6 centimeters, and y centimeters, where y is a real number. So, first thing that you might look at this question, these might be really confusing. So, why does it have to be a real number? So, don't worry about that at all. So, it's just a way of saying that it's a real number. So, mathematically speaking, they have to put it down. If you completely ignored the where x, where y parts, you'd be completely fine. So if those parts confuse you, don't worry about it. So let's have a look at part A here. So the volume of A is 216 centimeters cubed. Find the value of x. So let's look at how we approach it. So whenever we deal with the volume or the area, first thing that needs to pop into your head is, what is the formula for this specific shape? So for cubes, the formula is very simple. It's just length by width by height. That's for cubes and cuboids. So length by width by height, that's our formula. In this case, our length and width by and height, I'm just going to draw it out. Here we have a bit more space. So it's going to be x, which is our length, multiplied by x, which is our width, multiplied by x, which is our height. Now, x by x by x, that's the same as x cubed. So what I can say is x cubed is equal to 216. And then all I have to do is get the cubed root of both sides. So the cubed root of here, cubed root of here. These cancel each other out. And then the cubed root of 216, let's see what that will give us. So cubed root of 216, that's going to be 6. So x is going to be equal to 6 centimeters. That's our answer to part A. Now, for part B, part 1, we have to show that the surface area of B is 22y plus 60 centimeters squared. So here we're looking at the surface area. So what I'm going to be doing is I want to find the area of this, area of this, and area of this. So because we already use A and B, let's use C, D, E. So I'm going to call this side C, side D, side E. But then you might think, okay, what about the ones behind? So the one sort of behind C to the bottom and then to the left. All I have to do is get the surface area of C, D, and E and then multiply by 2. Because if you think about the ones behind, there'll be exact copies of C, D, and E. So I'll just find these and multiply it all by 2. So first let's do C. So it'll be the bottom here, y, multiplied by 5. So it'll be 5y. And because we're adding separate areas, they're not related in any way, we're just going to add them on. So 5y plus 6 by 5, which is going to be 30, plus 6 by y, which is going to be plus 6y. So I'm just going to add all of these together, which is going to be 11y plus 30. And now think back to sort of multiplying all of those by 2, so doubling for the other side. So I'm going to do 2 by 11y plus 30, which is going to be 22y plus 60 in brackets, and we're working with areas, so centimeters squared. So that's our answer to part B. Okay, then for part 2, for B part 1, that was our answer. So for B part 2, the surface area of B is 269 centimeters squared. Work out the value of y. Okay, this is pretty easy. We just have to do a bit of algebra. So we're going to say we found that the surface area is 22y plus 60. Even if you couldn't do part 1, if you couldn't get it, you can still use that because they actually give it to you in the question. So we do 22y plus 60 is equal to 269. What we're doing is really obvious because we have shown that the surface area of B is this, and then we're told that the surface area of B is this. So we're saying the surface area of B is equal to the surface area of B in a nutshell. So we're saying they're the same, but we have it written in two different terms. So we can say 22y plus 60 is equal to 269. What I'm going to do is I'm going to minus 60 from both sides. So we want to make sure that we just have the letters on one side, all the numbers on the other side. So we're going to get 22y is equal to 209. Now we want to get y by itself. So we know that 22y's is 209. So in order to get what one y is, we have to divide both sides by 22, which will give us an answer of 9.5 centimeters. And it's centimeters because if we go back here, y was a measurement. So that's why we give it in centimeters. Okay. Then to finish it off, we have part C. The area of three faces of a different cuboid are shown in the diagram below, not this scale. The dimensions of this cuboid are L centimeters by M centimeters by P centimeters, where L, M, and P are all whole numbers. So this is an important part, all whole numbers. So you have to work out the volume of the cuboid and give our answer in centimeters cubed. So first, let's write a few equations that we can here. So we can say M, L, so M by L will give us 96 centimeters squared. We know that L by P will give us 32, and we know that M by P, so the top, will give me 48. So that's what we know. Now, let's have a think about this. So the volume of the entire cuboid will be MLP. That will be the volume. Now, let's see what happens if we multiply all of these letters by each other. So I'm going to do ML multiplied by LP multiplied by MP. So another way of writing that is just without because the X can be confusing because we might confuse it for X instead of the multiplication that's supposed to be. So I'm going to write it like this in brackets. Then I'm going to remove the brackets. So it's going to be ML, LP, MP. And now something interesting happens. So M by M will be M squared. L by L will be L squared. And P by P will be P squared. So if I multiply all of these numbers by each other, I will get M squared, L squared, P squared. Now let's look at what happens if we square this. So if we square this, we'll just get MLP, which is our volume all the way up there that we talked about in this time. So in order to get the answer for this question, we have to multiply all of these by each other and then square our answer. So it might not seem obvious at first, but if you think about what we're doing here for a while, it'll become clear why we're doing all of this. So it's just algebra, the way the sides are related to each other. So what I'm going to do is I'm going to do 96 multiplied by 48 multiplied by 32. I'm going to get that on a calculator. So 96 times 48 times 32. And that will be 147456. 147456. And then if we get the square root of this, the square root of answer, that will give us a nice round number of 384 centimeters cubed. So that's our volume of the cuboid. The graph below shows the function g of x for x is greater than or equal to -2 and x is less than or equal to 3, and x is a real number. So we have to use this graph to answer the following questions. For part A, we have to write down the value g of 3. So the way we have to look at it is g of x is the name of the function. So g is the actual name of it. X is its input. So x is what it takes in. So if we put in the number 3 into our function, we will get some output. If we put 1, we got some output. If we put -1, we'll get some output. But in this question specifically, it's asking what do we get if we put 3 in. So 3 being our input, we will get an answer of 2. So our g of 3 will be equal to 2. Okay, then for part B, we have to write down the value of x for which g of x is equal to 1. So 1 will be our output in this case. So if we go across to here, the value of x for which g of x will be equal to 1 will be -1. So it's just working with the graph. So then for part C, we have to draw the graph of the function y of g of x -2 on the diagram above for the same limit, so from -2 to 3. Okay, so what it's saying here is we take g of x, so let's say g of 3 for example, that would be 2, and then we -2 from it and we go 2 down. So if you have a -2 like this on the function, all you have to do is just draw everything but 2 lower. So this point will be here, then it will go up to this point, which is 2 lower than here. So we'll draw this up here. Then, for example, this point will be down here, this point will be down here, and this point will be down here. So all we have to do is just get every point and draw it 2 lower. So 2 will be 0, 3 will be 1, 2 will be 0, 1 will be -1, -2 will be, 0. So 1 will be -1 and then 0 will be -2. So I think you get the point. And that will be question 8. The coordinate diagram below shows the line segment AC and the points B, 4, 1 and P, 3, 3. So for part A, we have to write down the coordinates of the point A and the point C. So with these ones, always x first and then y. So -1, 1, and then for point C, it will be 5 and 4. So we always go down, that will be our first point, and then across, that will be our second point. Down 5, across 4. For B, part 1, we are told that D is a point that's not shown. D is the image of the point B under central symmetry in the point P. What that means is that we have to think what would happen if it was sort of a mirror shape. So if we go from B to P, we have to extend that past. So can't draw a straight line here, but just imagine you extend that straight past P, it will end up here. So actually, let's draw that using this tool here. So that would be up to here. And then we have point D here. So that's under central symmetry. So what you do is you draw a line from B to P and true, and then you use a compass to mark off. You put your point P, you go to B, and then the same here. Or you could just use the grids to get the point. So then we want to draw the quadrilateral ABCD. So we'll just join all of these points here. So we have a four-sided shape. Okay, then for 2, Kate says the quadrilateral ABCD is not a parallelogram. Find the length of AB and CD and use these values to explain why K is correct. So first of all, let's talk about the theory. So we know that in a parallelogram, the opposite sides will always have to be equal. So if we find AB and CD and they won't be equal, that means that it will not be a parallel. So let's just do it on the right here. So the length AB. AB will be the easier of the two because it's a straight line. So the height doesn't change at all. So it's literally just this distance here. So from -1 to 4. So that will be a distance of 5. Now, to find the distance from C to D, we can either use the distance formula or Pythagoras theorem. So whichever you prefer. I myself prefer to use a Pythagoras theorem, so we'll do it like this. By the way, the distance formula is Pythagoras theorem, but we can sort of do it ourselves like this. So from D to C, we're going down 1. So this side of our triangle will be 1, and we're going across 3. So this will be 3. Now, once we find the hypotenuse, that will just be our distance between them. So all we have to do is 3 squared. So let's just call this side A. 3 squared, or to keep this sort of the same as the form, let's call it C. So 3 squared plus 1 squared will be equal to C squared. Let's square root both sides. 3 squared plus 1 squared is equal to C. So the square root of 3 squared is going to be 9 plus 1 is going to be 10. The square root of 10 is equal to C. So the length of CD is equal to the square root of 10. If we want to write that as a number, so we want to do square root of 10, that will be 3.16. So we want to explain why K is not correct. So we can say 3.16 is not equal to 5. So the length CD is not equal to the length AB. So this sign here just means not equal. And that is our answer to B, part 2. The equation of the line K is y is equal to 2x plus 5. The line K intersects the y-axis at the point 0, 5 and the x-axis at the point P. Find the coordinates of the point P. Okay, so in order to find the coordinates, we have to take into account a few things. So first, we know that the equation of the line is y is equal to 2x plus 5. So let's just write that y is equal to 2x plus 5. Now, we know 100% that at point P, y is going to be 0 because it's touching the x-axis. So we can already fill that in. We can also fill it in here. So we can say 0 is equal to 2x plus 5. From here, notice we only have one variable, which means that we'll be able to solve this equation. So I'll just flip it the other way, just so it's a bit easier to look at. So 2x plus 5 is equal to 0. What I'm going to do is put all the letters to one side, numbers to one side. That will give us 2x is equal to minus 5. Then I'm going to divide both by 2. X is equal to minus 5 over 2. So I'll just put that here, minus 5 over 2. So that are our coordinates of point P. And we also just want to think, does our answer make sense? And yes, that does look around minus 5 over 2, as that would be like minus 2.5. So it's sort of right behind the y-axis there. For part B, the line N is perpendicular to the line K and goes through the point 0, 10. Find the equation of the line N. Give your answer in the form ax plus by plus c is equal to 0, where a, b, and c are all integers. So the important thing to understand about lines that are perpendicular to each other is how to get the slope from one to another. So just looking up here, we know that y is equal to 2x plus 5. So I already know that the slope of k is equal to 2. How do I know that? We have the formula y is equal to mx plus c. Y is y, m is 2, x is x, c is 5. M will always be the slope, c will always be the y-intercept, which matches up. C is 5, so m2 has to be the slope. And if you don't have it in this form, then you have to write it in this form. So switch stuff around until you have it in the form y is equal to mx plus c. Then you can get the y-intercept and the slope. Then from here, actually another way that we could get the slope, I'll just go through that quickly, is we have this point here, minus 2.5 and 5. So we have a rise of 5 and a run of 2.5, so or 5 over 2. So from here to here is 5 over 2, up here is 5. So if we do 5 over 5 over 2, that'd be the same as, so I just multiply both the top and bottom by 2 to get rid of the fraction at the bottom. That would be the same as 10 over 5, which will be the same as 2. So those are two ways to find the slope of k. So the way that we find the slope of a perpendicular line, in this case n, so slope of n, is, so 2 is the same as 2 over 1. To get the slope of n, we have to flip the fraction. So first let's flip the fraction. So that would be 1 over 2. And then we put a minus in front of it. Now, if it was a minus, we'd put a plus. If it's a plus, we put a minus. So we switch the sign. So we flip it and we switch the sign. So 2 will switch to minus a half. So I know that the slope of n will be minus a half. Okay, and from that, I can actually get the equation of the line n just by using this. So I could say y is equal to, so our slope is minus a half, x plus 10, which will be our y-intercept. So now we have the equation of line n. All we have to do now is give it in the form that they wanted. So ax plus by plus c is equal to 0. So I'm going to put everything over to the left-hand side. So minus half x will switch to half x. This will be plus y plus 10 is equal to 0. And then a is a half, b is 1, c is 10. So they're all integers, giving us the answer for part B. Work out the value of 12 minus 3k squared when k is equal to minus 2. So we know that k is equal to minus 2, which pretty much means they're the same. So what we can do here is take the k, completely replace with the minus 2, because remember they're the same, and that will give us our answer. So we can do 12, 3, and then I'm going to, in brackets, I'm going to replace the k with minus 2, and that will be squared. Now here, it's very important that the order that we do things in. So first we'll do minus 2 squared, which will be 4. We multiply that 4 by 3, so we'll do 12 minus 12, and that will be 0. Next, we have to factorize fully pm plus 3p minus m minus 3. So first thing that I'm noticing is that the pm and the m and the 3p and the minus 3, sort of, they work together. So I'm going to reorder this a bit. Now I could do the p to the p, but then the m and the 3 have nothing in common. So I'll do pm minus m plus 3p minus 3. Okay, then I'm going to do highest common factor here. So I can see pm minus m, so they have the m in common, so I'm going to put the m in front. Then I'm going to do p minus 1. And then here I can see they have the 3 in common, so I'm going to do plus 3 then the p, and the -1. So we do outside of the brackets, we do what's the same about them. So in this case, m. Then inside we put what's different. So what makes it different is the p. What makes it different is the minus sign. So we put -1. Then this p minus sign again. So if you do it correctly, you should always get the same sort of sequence in both of the brackets. We have a p -1 here and a p -1 here. So our final answer will be m plus 3 multiplied by p minus 1. Now what you could do is multiply these back out. Now this is completely optional. This is only if you have time during the exam. You multiply them back out, see if they give you the same thing. So it's sort of a way of double checking your work. And if you match those up, MP, that's the same as PM, 3P here, minus M here, minus 3 here. So those will match up. So it's just a way of checking it. For part 2, we have to graph each of the following inequalities on the number line given. So we have to graph x is less than 2, where x is an integer. So x will be integers. So we have to be very careful about what we'll select. So 2 won't be because it has to be less than 2. So it'll be 1. So I'll just draw dots on all of these. Because 0.5, for example, will not be 1. And why? Because we're looking at integers only. And integers also include negative numbers. So I'll just select all of these. X is less than or equal to 3, where x is a natural number. So we want to select 1, we want to select 2, and we want to select 3. Because remember, it's less than or equal to 3. Now, 0 is a bit of a weird one. Sometimes 0 counts as a natural number. Sometimes it doesn't. So if you're ever unsure, because there are different definitions, you can always check in your formula book whether it's a natural number or not. So if you go to page 23, for these exams, we don't consider 0 a natural number, so we'll leave it out. But in some definitions, they do. So for now, while you're in secondary school, just always remember 0 is not a natural number. Okay. Then here we have this time real numbers, so we'll include all the ones on the number line. So we are told -2, so x is greater than -2 and less than or equal to 4. So when, for example, the number -1.9999, it'll get very close to -2, but it'll never touch it because it has to be greater than. So what we have to do is draw sort of a circle like this. This shows it gets very close, but doesn't actually touch. And then we'll just shade in the whole line, like so, because we have all of these numbers, they're all real numbers. Now 4, it actually does touch. It says x is less than or equal to 4. So we'll draw a dot here on 4. And that will be how we will answer question C. Then to finish it off, we have part D. We have to write the following expression as a single fraction in its simplest form. So the key thing here is whenever you want to add fractions together, they have to have the same denominator. And just by changing these fractions a bit, we can actually change the denominator. So I'm going to make the denominator of both of these 3 by 5x plus 2. And how did I get that? Just by multiplying these denominators. So in order to get this denominator on the left-hand side, I'm going to have to multiply the top by 5x plus 2. So this here is going to change to 5x minus 2 multiplied by 5x plus 2 over 3 by 5x plus 2. Now the reason I'm doing that is so that I can have the same denominator at the end. So now I'm just going to multiply this out. So I'm going to multiply the top here just using a box method up here. So I'm going to do 5x minus 2 by 5, so 5x minus 2 by 5x plus 2. So this will be 25x squared, this will be minus 10x, this will be 10x, and this will be minus 4. So this top will be equal to 25x squared. Then I'm going to add the minus 10x and the 10x. They'll actually cancel each other out. And then at the end, I'll have minus 4 all over 3 by 5x, which is 15x, and 3 by 2, which is 6. And then this here is going to change to 2 by 3 by 5x plus 2 by 3. So the order in which you're multiplying doesn't really matter. So this would be 6 over 15x plus 6. So now I can change all of these and I can say 25x squared minus 4 over 15x plus 6 plus 6 over 15x plus 6. So now notice this. Now we have the same denominator, which means that we can just add these tops together. Once we do that, we will get 25x squared minus 4 plus 6, that would just be plus 2 over 15x plus 6. I'm just going to have a double check. Can I divide by anything here? And I cannot, so this is the fraction in its simplest form. The first 3 patterns in a sequence are shown below. Each pattern consists of white squares and shaded squares. So we have pattern 1, 2, and 3. In pattern 1, you can see that it's a 3 by 3 with the shaded square in the top right and the diagonal going from top left to bottom right. And then you can see the same thing but with 4, 5. So then if we want to draw pattern 4 in the sequence, we should have also drawn the lines across here. That will take a good bit of time. So you want to do that with a ruler. So then this one will be 6 by 6, line going across, and a shaded square in the top right. So we'll have a look at part B here. So complete the table below to show the number of shaded squares and the total number of squares in the sequence. So here, the number of shaded squares in pattern 2 will be 5. The total number of squares will be 16. In 3, it will be, so shaded squares will be 6. Total number of squares will be 25. And then this will just be 7, so this must be 8. This is 5 squared. So this will have to be 6 squared. So this will have to be 7 squared, so 49. So we can see that this is n plus 2. So we do 3 plus 2 squared, which is 25, 4 plus 2 squared, which is 36, and then 5 plus 2 squared, which is 49. And then they're just asking us to give your answer in the last row in terms of n, where n is a natural number. So you can either do this using the formula or just by looking at it. So this is going to be the same, but plus 3, plus 3, plus 3, plus 3. So we could say this here is n plus 3, just to sort of describe the pattern that's going on. Okay, then for part C, in pattern K, the difference between the total number of squares and the number of shaded squares is 271. Show that this means that k squared plus 3k plus 1 is equal to 271. Okay, so the difference is something that we obtain by subtraction. So, for example, we always want to start with very simple examples. The difference between 5 and 2 is 3. So it's 5 minus 2 is 3. So total number of squares, that's going to be n plus 2. In this case, k. So it's going to be k plus 2 squared minus k plus 3. So I'm just copying from up here. We're replacing all the n's with k's because we are told in pattern k. And this will be equal to 271. So let's just work this out. So I'm going to do k plus 2 in a box here. K plus 2. I shall make this a little bit bigger here. So we have a box. So k plus 2, k plus 2. This will be k squared, 2k, 2k, and 4. So I just did the k plus 2 squared here. So k plus 2 squared is the same as k plus 2 by k plus 2, which we can either do in your head, if you're able to do that, or if you struggle with that, you can use the box method. So just for those that want to do it faster, what you have to do is square the first, so k squared, then do the first by the last, which is k by 2, 2k, then you double that, so k squared plus 4k, and then you just square the last, so k squared plus 4k plus 4, which is the same as we have here, because the two k's will go together. So k squared plus 4k plus 4 minus k plus 3 is equal to 271. Now what we have to do is just put the like terms together. So there's no more k squared, plus 4k minus k, that will be plus 3k. Or sorry, this here should be, because it's a minus, so this should have been put in brackets. So this here changes to a minus 3 actually. So then this will be 4 minus 3, that will be plus 1, is equal to 271, which is what we have there. So that's how we show that this phrase translates into this equation. Okay, so then for this one here, we have to solve this equation to work out the value of k. So even if you didn't get the last part, you could still do this part. That's often the case, where you don't necessarily need the previous part to answer. So even, let's say you get stuck on C part 1, just keep on going with C part 2. So the way that we answer this is we need to recognize first that this is a quadratic. So we're going to have to put everything over to one side, make it equal to 0. So I'm going to say k squared plus 3k, and now I'm going to minus 271 from both sides, which will give me minus 270 here, is equal to 0. Now, whenever we want to answer a question like this, we have to use the minus b formula. So for factorizing quadratics, we use the box method. For solving quadratics, which is what we're doing here, solving, we want to use the minus b formula. So I'm going to get a, b, and c. So a is going to be 1 because it's 1k squared, b is going to be 3 because it's 3k, and c is going to be minus 270. So I'm going to do minus 3 plus minus 3 squared minus 4 by 1 by minus 270 all over 2 by 1. That's our minus b formula, which you have in your formula book. So I'm going to have two answers here, so I'm going to have to write this out twice. So minus 3 plus the square of 3 squared minus 4 by 1 by minus 270 all over 2. That will give me an answer of 15. And then we always have to get our negative value, so I'm going to replace it with a minus. We'll get minus 18. Now, this quadratic has two answers. That doesn't necessarily mean that we will have two answers to our question. The reason for that is we can't have a pattern minus 18. We can't go backwards in patterns. So this here cannot be an answer. So our value of k will be k is equal to 15. Michael is designing the roof of a house. The width of the roof is 6.1 meters. The roof will be in the shape of a right angle triangle of height h, where h is an element of R. Michael can choose different values for h. The diagram below shows one possible design for the roof, not the scale. Calculate the slant height, x meters, of the roof of this diagram. Correct the two decimal places. Okay, whenever you see a right angle triangle, just think about two things. It's going to be either sine cos tan, or it's going to be Pythagoras theorem. In this case, we're working with two lengths, and our answer will also be a length. So we're working with only length. That gives us confirmation that this will be Pythagoras theorem. So we're going to have to use a squared plus b squared is equal to c squared. So let's just fill it in. 6.1 squared plus 2.84 squared will be equal to c squared. So the square root of 6.1 squared plus 2.84 squared will be equal to c. So if we do that on the calculator, that will give us an answer of 6.73 meters. Correct the two decimal places. So this would be 6. This was actually 6.7287. So because we have an 8 here, we'll round up. So we wanted our answer corrected to decimal places. Okay, for part B, the diagram below shows a different design for this part of the roof. Use trigonometry to work out the size of the angle marked theta in the diagram. Give your answer in degrees, correct the nearest degree. So as we were saying before, we want to think of either sine, cos, tan, or Pythagoras. In this case, we're working with two sides on an angle, therefore our brain should automatically go to sine, cos, tan. So here we will be working with the opposite angle and the adjacent one. So that means that we will be using tan. How do we write that out? So the way I like to remember it is sa, ka, and toa. Sa, ka, toa. And then by saying opposite and adjacent, I see that it's here. So it's going to be tan of theta, so we don't know what it is equal to opposite, which is 3.12, over adjacent, which is 6.1. Now, we won't be able to solve for theta like this. We might think, oh, you just have to divide both sides by tan, but in trigonometry, it doesn't work by that. We'll have to switch the places of theta and the fraction that we have and use tan inverse. So tan inverse allows you to switch those places around. So like this, where 6.1 is equal to theta now. And now to get theta, all I have to do is just use my calculator and fill what we have written on the page in. So that will give us correct the nearest degree, 27 degrees. So make sure to try this on a calculator and make sure that you know where to get all of the buttons. So tan minus 1 on a Casio calculator is done by pressing shift and then tan. Okay, let's have a look at the next part. A different part of the roof is in the shape of an isosceles triangle. So as soon as we see stuff like that, isosceles triangles, we want to think, okay, two equal sides, two equal angles, with base 14 meters. So we see that in the diagram there. In this part of the roof, Michael makes an attic room by putting the two vertical side walls, AB and DC, shown in the diagram below, not to scale. So the distance from B to C is 8 meters. So 4 meters from either side. The total height of the roof is Y meters, and AB is equal to DC. So that seems, so AB is equal to DC, which is equal to X, and then we're just told that all the numbers are real numbers. That seems like a whole lot of information. So it's all sort of thrown at us. So we want to take it all bit by bit. We don't want to get overwhelmed. We have all the information that we need in the diagram. Let's now have a look at the question. So we want to use similar triangles to show that X is equal to 3Y over 7. Okay. So similar triangles to show that X is equal to 3Y over 7. Okay, so we want to draw this triangle out. So this will be X. And then we want to extend this one here. This will be our bigger. So Y. And now, so I'm just looking at the left half of the triangle here. Up to here, this will be 4. Then from here to here, it will be 3. And we know that this entire distance is 7. So how did I get that? This is right the middle point. So of this, it's going to be 7 here and 4 here. So remember that this is 8. So 8.5 will be 4. And then this here will be 3. So what I can say is the relationship between X and 3 is the same as the relationship between Y and 7. So what I'm saying is right side over bottom is equal to right side over bottom. So we're using those similar triangles. So we know that these are similar triangles. So I'm using AB and this point here and E to the bottom and this point here. So just sort of help you visualize A, E, and B. So I'm saying the right side to the bottom and the right side to the bottom for both of the triangles. That relationship is equal because with that fraction, we're describing the ratio, we're describing the relationship. Then to show this, all I have to do is just multiply both sides by 3. If I multiply both sides by 3, I will get x is equal to 3y over 7. Now, this might seem like a completely random equation that we're given at the start. And you might think, how can we prove that? What you want to do is find the similar triangles, so like we have here, and then what I did was just wrote out the relationship in some way. Even if you did 3 over x is equal to 7 over y, you'd get there eventually to get to that answer. You just have to move stuff around. So it's just a case of trying stuff out and trying to get to that equation that they want you to get. Okay, so that's part 1 done. The area of the shaded region ABCDE in the diagram is 12 meters squared. Using your answer from part C, part 1, or otherwise work out the value of y. So looking at this one, the easiest thing to do seems to be getting the area of this rectangle here, and then getting the area of the triangle up top later. So first, let's focus on the rectangle. So the rectangle will just be length by width, which will be 8 by 3y over 7, or 8 by x, but remember x is now equal to 3y over 7, so we can use that. And that will be 24y over 7. So that will be the area of the rectangle. So now we want to look at the area of the triangle up top here. So that will be, our base will be 8. So remember, the formula for the area of a triangle is half the base by the perpendicular height. The base by the perpendicular height, which will be half. The base will be 8. So getting that from here, it's the same sort of as the length of the rectangle. And then the height, that will be y minus x. So it'll be the difference between y and x. So it's all y taken out the x. So it'll be y minus 3y over 7. So half by 8, that would just be 4 by y minus 3y over 7. And then let's just multiply that out. So that would be 4y minus 12y over 7. So now if we add this area, so this is the area of the triangle. So if we add the area of the rectangle and the area of the triangle, they should both equal together to 12. So let's just do that now. So we'll say the rectangle is 24y over 7 plus 4y minus 12y over 7 is equal to 12. Now we just have to solve this. So first I'm going to do 24 minus 12y, so that will just leave me with 12y over 7 plus 4y is equal to 12. Then I'm going to try and get rid of this fraction that we have here. So we'll do multiply everything by 7. So 12y plus 28y is equal to 12 by 7, which is 84. So 12y plus 28y, that will be 40y is equal to 84. So is equal to 84. Then we just divide both sides by 40. And y will be, so 84 divided by 40, y will be 2.1 meters, which if you think about the height of a roof, makes sense, and that will be our answer.